All right. Hello, everyone. So, as promised, I'm going to be recording a video on our cap and trade problem and just going a little bit deeper into how we go about doing cap and trade in general. So, we start with the example where the world price for widgets is $10, and suppose there are two domestic firms that produce widgets, sorry. Firm 1 supply function is QS is equal to P minus 5, and firm 2 supply function is QS is equal to 2P minus 10. So usually what I tell my students to do is that whenever we're giving a function that is a direct demand function, I tell them to convert it to inverse demand function. And what that means is P in terms of Q. So in this case, Q is equal to P minus 5 would be P is equal to Q plus 5. And then for our second function, we would have 2P is equal to 10 plus Q. We divide by 2. That should be 5 plus 1/2 Q. So our two inverse demand functions are going to be P is equal to Q plus 5 and P is equal to 5 plus 1/2 Q. So the questions being asked are, unfortunately, producing widgets is a dirty business. So the government wants to restrict the total quantity of widgets produced to 10. That means that each person can only produce 5 widgets because it gives each firm 5 permits. The first question is, what will be the total domestic production before the government implements the cap and trade scheme? What would be the total producer surplus? So to find out what the total domestic production would be, first, we have to remember our inverse demand functions. P is equal to Q plus 5, and then P is equal to 5 plus 1/2 Q. So these are going to be our production functions. Now, we also need to remember that the world price is 10. So similar to how we did a few weeks ago, or what you should have done in your recitation with efficient production, first, we're going to set our world price at 10, and then we're going to graph our two production functions. So as you can see, our y-intercept is going to be 5 in both cases. But this production function has a smaller slope, so that means it's going to be flatter. So our first production function is going to look something like this. And our second production function is going to look something like this. Awesome. So to answer the first question of what will be the total domestic production before the government implements the cap and trade scheme, all we need to do is find where our production functions cross the world price and solve for Q1 and Q2. So we do that by setting each function equal to 10. So Q1 is going to be 5. Now we do the same thing for the other function. 5 is equal to 1/2 Q. So Q2 is going to equal 10. So Q1 is equal to 5 and Q2 is equal to 10. That's before cap and trade, and we know that because Q2, in this case, is producing more than 5 widgets. So now it's asking us what would be the total producer surplus. Producer surplus, a good way of remembering it, is going from the price at which we're selling all the way down to our marginal cost function. So in this case, we're selling at a price of 10. And we're going to go down to our first marginal cost function. And that'll give us the producer surplus for consumer or producer 1. We do the same thing with producer 2. In this case, we start at 10, we go down to our marginal cost, and it's going to be this bigger triangle, including the surplus of Q1. So to find this surplus, what we're going to do is find the area of the yellow rectangle and the big blue triangle. Sorry, not rectangle, triangle. So the total surplus would just be 1/2 times the base of the triangle, 5 times the height of the triangle. So this is going to be for producer 1, plus, now we're going to find the area of the big triangle, 1/2 times 10 times 5. This is going to be the area for producer 2, and give us a total producer surplus before the cap and trade scheme of 35. Now the next question is asking, what will be the total surplus under the cap and trade scheme? Well, we still are going to have the same production functions, but this time, each producer is only allowed to produce 5 widgets. So our producer surpluses are going to be different. First, let's find the producer surplus for producer 1. It's going to be from the price that he sells his good at down to his marginal cost curve. And it actually ends up being the same producer surplus that he used to have, right? And we know this because Q1 is equal to 5, Q2 is equal to 10. But if the first producer is already producing 5, even before the cap and trade scheme, then we know that he's not going to care. So he's just going to keep producing 5, and he's going to end up with the same surplus. But for producer 2, what ends up happening is that his producer surplus gets cut at Q is equal to 5. So his producer surplus ends up being this trapezoid right here. So the loss of his producer surplus is this red triangle here. So in order to find the area of our total producer surplus, we get our original total producer surplus, and then we subtract the area of this triangle. How do we find the area of that triangle? Well, all we do is 1/2 times the base, which in this case is going to be 2.5 times 5, which would be the height of the triangle. And that should give us 6.25. So our total producer surplus ends up being 31.25 with cap and trade. Or in this case, with a cap on how many widgets each producer can produce. All right, so we're attempting to answer the question, suppose the permits are tradable. Would any permits get traded? And which firm would buy permits and which firm would sell permits? So what we're going to do is, right now we're at a starting point where firm 1 has 5 units and firm 2 has 5 units. We want to figure out, would they trade? And if they do trade, who would be selling their permits to who? So first, let's figure out what firm 1's 5th unit is worth to them. So as we know from our graph, we're selling at a price of P is equal to 10. So let's call that selling price is equal to, let's call that actually PS, as we've been doing. So the price that sellers receive is going to be 10. So this is going to be their revenue. But in order to figure out the value of a unit for a firm, we want to figure out the profit that each unit brings. So how do we do that? Well, we know that profit is equal to revenues minus costs. So we're given a marginal cost schedule. And the way that we figure out these costs is we know that the supply curve is our marginal cost curve. So all we do is plug in the quantity that we're selling into our production functions. So for example, we're figuring out the value of the 5th unit. For those 5 units, we're going to be selling them at a price of 10. However, if we have our function, which is P is equal to Q plus 5 for firm 1, and we plug in the 5, our costs are going to end up being 10. Again, we know this because our supply curve is our marginal cost curve. So now that we have our revenues and costs, we can find out our profit. So firm 1's profit for their 5th unit is going to be 10, which is what they receive, minus 10, which is what that's going to cost them. That's going to be 0. So the 5th unit is going to be worth $0 to firm 1. So what that means is that firm 1 would be willing to sell their 5th permit or their 5th ability to create a 5th unit for any price above 0. So with that said, let's figure out firm 2 value of 6th unit. In other words, how much would firm 2 be willing to pay firm 1 for a 6th unit? So again, the price that they're going to receive is 10. So their revenue is going to be 10. Now, for profit, we're going to plug in P is equal to, in this case, 5 plus 1/2 Q. And because we're trying to figure out the value of the 6th unit, we're going to plug in 6 into our Q. So P is equal to 5 plus 3 to give us 8. So the profit that firm 2 would make from selling a 6th unit would be 10 minus 8 is equal to 2. And what this 2 means is that firm 2 would be willing to pay up to $2 for firm 1's 5th permit. So if we compare that firm 1 is willing to receive anything above $0 for their 5th unit, and firm 2 is willing to pay up to $2, will this trade happen? Yes, they're going to trade, and now firm 1 is going to have 4 permits, and firm 2 is going to have 6 permits. So that answers our first part of the question, which is, would any permits get traded? Yes. Which firm would buy permits and which firm would sell permits? Firm 1 sells permits, and then firm 2 buys. Now, we can actually keep going until they no longer want to trade. So now we're going to figure out firm 1's value of their 4th unit, and we're going to compare it to firm 2's value of their 7th unit. So the revenue is going to stay the same. It's going to be 10 for each. Then we plug in P is equal to 4 plus 5. It's going to be 1 for our marginal cost. So our profit is going to end up being 9. Okay. Oh, sorry about that. This is 9 marginal cost, and our profit ends up being 1. Now, let's do the same thing for firm 2. It's going to be 1/2 Q plus 5. You plug in the seventh unit is going to be 3.5 plus 5 to give us a cost of 8.5. So our profit in this case is going to be 1.5. So firm one is going to be willing to receive anything above $1, and firm two is going to be willing to pay up to $1.5 for firm one's fourth unit. So is this trade going to happen? Yes, it's going to happen. So we end up in a situation where firm one has 3 permits and firm two has 7 permits. And you can keep going like this. For example, now we would compare the willingness to receive in firm one for their third unit, which would be 10 minus 8, that would be 2. And then we compare it to the willingness to pay of firm number 2 for their 8th unit, which in this case doesn't exist, at least on this table. But you would go through the same process, and let's say that firm 2 is willing to pay 1 for the 8th unit. In this case, because the willingness to receive is higher than the willingness to pay, the trade won't happen. So you keep trading and trading and trading until it's no longer worth it to buy or to sell your permits.